In this video, we are going to talk about the IUPAC nomenclature of alkanes that has a complex substituent. What is a complex substituent? If a substituent has a substituent, then it is considered as a complex substituent. Look at these two structures. If I ask you to find out what is the difference between these two structures, then you might immediately point out that there is a additional ethyl group here that is missing on the left hand side. Other than that, everything else is same. So, let us do the IUPAC name for these two molecules, and in the process try to understand the complex substituent. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the substituents are at 3, 5 and 8 position if we do the numbering from left to right. On the contrary, if we do the numbering from right to left, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the substituents are at 3, 6 and 8 position, and therefore, the numbering that we did from left to right is correct in this case, because that gives the lowest numbers for the substituents. We have a methyl group, 2 methyl groups and 1 butyl group for this alkane. So, let us do the naming, that is not very difficult. So, between methyl and butyl comes first, so that we need to mention first, and therefore, the IUPAC name for this structure is 5 butyl 3, 8 dimethyl decane, because we have 10 carbon atoms in the parent chain. So, that is done, and now let us come to the structure on the right. Our numbering scheme is going to remain the same, and the only thing that we need to figure out is how to do the naming for the complex substituent. This is a complex substituent, this entire thing, and that is sitting at 5. In this case, we have an additional chain that we need to number it. We have a second parent chain 1, 2, 3, 4 that has a ethyl group. One, 2. So, that one we are going to write the entire thing in parenthesis. This entire whatever is shown in green, we are going to write it in parenthesis. That is how the complex substituents work. So, let us do the naming for the structure on the right. At 5, we have a butyl chain, and that has a ethyl group at 2 position, and therefore, write the entire thing first in parenthesis. So, at 5 position, we have a butyl chain that has a ethyl group. So, 2 ethyl butyl. That is the systematic way of naming that entire complex. This is the complex substituent. So, we have done that, and then the rest of them will remain the same. 3, 8 dimethyl decane. It's just one word, just a space is not there. So, that is why I just wrote down the decane below. So, 5 hyphen in parenthesis 2 hyphen ethyl butyl, because the butyl chain has a ethyl group at 2 position. Okay. So, this 2 basically refers to this one. So, in parenthesis 2 ethyl butyl and then 3,8 dimethyl decane. That is the correct IUPAC name for this molecule. So, before talking about further examples, let us talk briefly about systematic names versus common names for complex substituents. While discussing the IUPAC nomenclature of alkanes, we already spoke about how to get the complex substituent by knocking out one hydrogen atom and their common names. Here what we are going to do is we are going to write down their systematic IUPAC names. The important point that I would like to share with you here is IUPAC recognizes both of these nomenclatures, especially for 3 carbon and 4 carbon chains. For substituents like isopropyl, isobutyl, secondary butyl and tertiary butyl, those are all common names. You can either use a common name or a systematic IUPAC name. It depends upon the question. If somebody is asking you to write a systematic IUPAC name when there is an isopropyl group is there, then that time you have to use the systematic name. You cannot use isopropyl. Okay, so we will discuss about that in this section. So you already know that this is isopropyl. Let us say R is your main chain. So the systematic name for this would be 1, 2. Always start numbering where the main chain is connected. Do not start numbering from here. That would be wrong. So the systematic name would be 1 methyl ethyl for the isopropyl, and then let us move to the butyl chains. So we know that this is secondary butyl. We write it as sec hyphen butyl, and by the way, while alphabetizing these names, B is what counts, not S. Okay, but for isopropyl, I gets alphabetized, not P. Okay, so the reason why we call it this as secondary butyl is because you might be thinking that this is a tertiary carbon here, why we are calling it secondary butyl. And the reason is when you have butyl chain, so this is your butyl chain, this carbon is secondary, this carbon is also secondary. When you knock out one hydrogen from either of one of these places, then you get the secondary butyl group, and that is why it is called secondary butyl. Okay, not because currently it is tertiary. Once it gets attached to a main chain, this carbon becomes tertiary, but before knocking out that hydrogen, this carbon is secondary, and that is why it is called secondary butyl, just to not to get confused about this naming. Okay, so now let us do the systematic name for the secondary butyl. So as usual, start numbering from here, 1, 2, 3. So this will be 1 methyl. Once again we have a methyl group at one position, and then propyl. That is the systematic name for secondary butyl. Let us go to the next one. Now let us say we have a group like this. This is isobutyl, that is the common name, and what would be the systematic name for this? Please feel free to pause the video and write it yourself and then come back and check it. So 1, 2, 3. 1 methyl 1 second 2 methyl 1 second 3 methyl 1 second 2 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 methyl 1 second So, this will be 2-methyl propyl, and when we alphabetize, I once again counts, not B, for isobutyl, and then tertiary butyl. This is the tertiary butyl, that is the common name. We write it as tert butyl, tert hyphen butyl or T butyl. It is alphabetized with the B, not T. Okay. So, 1, 2, and therefore, the systematic name for this is 1, 1 dimethyl ethyl. Once again, this is a quaternary carbon right now, but if we have a isomer of one of the C4H10s, this is one of the isomers, and that is actually 1, 2, 3. This is basically 2-methyl propane, that is the isomer you have. So, you are basically knocking out this hydrogen, but this is tertiary carbon, and that is why it is called tertiary butyl. Okay. Not because currently it is quaternary, but before knocking out the hydrogen, that carbon is tertiary, and that is why it is called tertiary butyl. For neopentyl and isopentyl, those common names are no longer allowed. You cannot use those common names in the current IUPAC nomenclature, but we will just write down their systematic names. So, if it is neopentyl, it will be like this. So, 1, 2, and therefore, the systematic name for neopentyl will be 2, 2 dimethyl 1, 2, 3, sorry, 1, 2, 3. So, 2, 2 dimethyl propyl. This is neopentyl, the common name, but that is no longer allowed to be used. So, you have to use the systematic name in this case, if it is a neopentyl group. And then isopentyl, that would be this one. 1, 2, 3, 4. So, 3-methyl butyl is the systematic name for isopentyl. You are no longer allowed to use the isopentyl, you have to use the systematic name. So, watch the question carefully. If they have given a tertiary butyl group, for example, and just said like you are allowed to use the common name, so in that case you can use the common name. But if they have given a tertiary butyl group and if the question paper specifically says that give a systematic IUPAC name, just note for that word systematic. If it is written systematic IUPAC name, then you have to use the systematic IUPAC name, you are not supposed to use the common name. Okay. So, let us go to more examples. Let us discuss one example and let us give names using both common names as well as systematic names. So, let us say we have a molecule like this. So, let us use the common name for the complex substituent and let us give the IUPAC name. So, 1, 2, 3. So, our parent chain here is obviously cyclohexane, but is the numbering scheme that we wrote is correct? Yes, it is correct, because between isopropyl and methyl, isopropyl comes first. In terms of alphabetical order, we need to give preference to that, because even if you go on the other way around, you will still get 1, 2, 3. But to break the tie, we have to use the alphabetical order, and therefore, the correct IUPAC name for this is 1 isopropyl, 3 methyl cyclohexane. This is using common name for the complex substituent. But now let us do the naming using systematic name for the complex substituent. So, in that case, so let us redraw the structure. Now, how to do the naming? Keep it in mind that while using the systematic name, we have to alphabetize everything that comes in the parenthesis. So, at first this will be 1 methyl ethyl versus methyl, because the isopropyl systematic name what we have seen is 1 methyl ethyl versus methyl group that is here. So, between methyl ethyl and methyl, methyl wins, and therefore, now you have to adapt to a numbering scheme that starts from here. That is correct. 1, 2, 3, 4, 5, 6, not on the other way around. If you choose the other one, then as you are just breaking the alphabetical order. So, the correct IUPAC name for this molecule is 1 methyl and then 3 and then in parenthesis 1 methyl ethyl cyclohexane. That is the correct IUPAC name for this molecule using systematic names for the complex substituent. So, this difference you need to understand. So, here it is between I and M, and that is why we chose that numbering scheme, but when we are doing the systematic naming, the alphabetical order is between methyl and methyl ethyl. So, methyl wins, because after methyl there is nothing is there, but here after methyl you have ethyl E. So, therefore, methyl wins, and therefore, you have to give 1 to the methyl, not 3 to the methyl. Okay? That is the point I would like to convey through this example. Let us look at one more example. Let us figure out the IUPAC name for this molecule. In this case, our long continuous carbon chain is obviously this one, because that has 9 carbon atoms. So, number it 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the correct way of numbering, because if we do it on the other way around, then it will be 5 and then 8. If we do numbering from right to left, then you will have a 5 and 8. Your substituents will be at 5 and 8. So, 1, 2, 3, 4, 5, 6, 7, 8, 9. We do not need to do that. We always have to go for substituents that gets the lowest numbers. So, 2 and 5. This is correct, and this is our complex, this entire thing is our complex substituent. So, let us do the numbering for that one too. 1, 2, 3. One common mistake sometimes students do is they start numbering from here. They think that this butyl chain is the long chain here. No, you have to always start your numbering where the branch is attached, where the entire group is attached. So, that is where you need to start. So, we basically have 2 methyl groups here. Okay. You should not start numbering from here, you should not start numbering from there. So, only 3 carbons in the second parent chain, and then that has 2 methyl groups, this one as well as this one. So, let us do the naming. So, at 5 position we have a propyl chain that has 2 methyl groups, and therefore, the correct IUPAC name for this molecule is 5 and then 1, 2 dimethyl propyl and then 2 methyl nonane, because we have total 9 carbon atoms on the main parent chain, and therefore nonane. And by the way, keep it in mind that when we do alphabetize this di, tri, tetra, all those things for a complex substituents, we need to take into consideration only for the complex substituent. In the normal cases, we ignore the di, tri, tetra, all those things, but when it comes to complex substituents, we have to consider those. This is an exception, just to try to remember that. That is the correct IUPAC name for this molecule. Alright, let us look at one more example. So, here the question is, give IUPAC name for the following molecule, use common name as well as systematic name. So, let us first use the common name and then later on we will use the systematic name. But first we need to figure out the long continuous carbon chain. Let us start numbering 1, 2, 3, 4, 5. If we go down that way, then we will end up with only 7 carbon chain. So, we should not do that. So, that is not our long continuous carbon chain, and therefore, our long continuous carbon chain is obviously this one. We have 9 carbon atoms. So, this is our long continuous carbon chain, and we have 2 tertiary butyl groups attached at 5 position, and therefore, using common name for the complex substituent, the IUPAC name is going to be 5, 5, because we have 2 tertiary butyl groups, di, tert, and then hyphen, butyl nonane. That is the correct IUPAC name using the common name for the complex substituent. Now, let us look at how we can use the systematic IUPAC name. For the tertiary butyl, it is 1, 2. So, basically for tertiary butyl, the systematic IUPAC name is 1, 1 dimethyl ethyl. That is the systematic IUPAC name for the tertiary butyl group. But now, we cannot use di in this case. When we are using complex substituent, when we are giving systematic name, the that we have to use is bis. If we have two things, if we have 3 groups, then tris. If we have 4 groups, then tetrakis. If we have 5, pentakis, and so on so forth. That is the one we should use when we are using complex systematic name for the complex substituent. We cannot use di or tri or tetra. That we can use when we are using common names. When we are using common names, you can use these prefixes, these numeric prefixes you can use. But when you are using complex substituent and you are using a systematic name, then you have to use this one. This is another thing that you need to keep it in mind. Okay? And therefore, the IUPAC name using systematic name for this molecule is going to be 5, 5 and then bis, and then in bracket 1, 1 dimethyl ethyl nonene. That is the correct IUPAC name for that molecule using systematic name for the complex substituent. Thank you for watching this video, and if you do like this video, consider subscribing it to Chem Media. Thank you.